Well, welcome back to Engineering Open House Day Live. What a live-a-thon we've got today, where we're going to give you a full day of exclusive inside access to organisations right across the country, where you can learn what engineers do behind the scenes to engineer us a better world. Let's have a quick look at what we've got coming up in store for you today. We launched the Engineering Open House Day Live with an amazing first episode that took us to outer space. We met epic engineers, including Sophie Harker and Jack Hesselwood. And don't worry, if you've just tuned in, all the episodes will be available on demand for you to enjoy throughout the summer holidays. But coming up now, we're sparking your interest all about electricity in episode 2. Then after, we will be revving those engines as we explore the world of transport engineering in episode 3, before powering our brains with our energy and sustainability episode. And then we're going to finish off our jam-packed show with our innovation episode to see what the world of engineering tomorrow could bring. Throughout the day, we're going to be joined by some pretty cool engineers who are going to give us an insight into what they do. Plus, they will be taking part in our Engineering Open House Day Challenge. I'm Mark, your host for the next hour, and I'm joined by one of the coolest engineers, my co-host and IET president. We met briefly earlier, Danielle George. How are you, Dan?
I'm very well, thank you. I'm very well, thank you. How great is this?
Brilliant, isn't
I'm
it?
loving it. I'm loving the aeroplane. I'm a bit nervous about mine.
I know, poor Sophie, she really built it. It was like an origami
So
folder.
good.
It was lovely. It had little, and it just,
Yeah.
I don't think there's enough. I think she bottled it. Anyway, we'll see what happens.
Let's see.
So,
Yes.
what's going to be happening
yes,
later?
I know,
Let's
yes.
have a look.
Hi to everyone. Hi to all of you at home. I hope you're having a fun time with us today and are being inspired by all the engineers and technologists. I love to hear what our engineers are doing to engineer us a better world. And one day, one of them could be you at home. Mark, did you know that the engineering jobs that our viewers will do at home in the future don't even exist yet?
What do you mean by no? What do you mean by that?
I know, yeah, it's crazy,
So
isn't it?
they're going to be doing jobs that don't exist?
Yeah,
That's bonkers.
At the moment, they don't even exist because our world is changing so quickly. Our technology is being developed at such a quick speed that the world is constantly being innovated, and the jobs that are about for engineers today will be completely different in years to come. How cool is that?
I guess, there was no mobile phone engineers 30 years ago because there were no mobile phones.
Exactly.
I know.
Yeah.
So that's amazing, isn't it? So one day, one of you at home could be, let me think of something. I don't know, you could be a software developer for like lightning trainers that could let you like lace them up and then you could fly off as fast as rocket jets or something like that. Would be great, wouldn't it?
You wear a t-shirt like yours as well.
Well,
Nice.
obviously,
Yes, nice.
obviously.
Engineers are always innovating, whether that be in healthcare, fashion, sport, climate change, or even energy and electricity industries.
Oh, that's brilliant, isn't it? We've got to learn from the engineers of today. If you want to learn real loads about everything that's going on, you can head over to our Media Hub, where you'll find tons of virtual events being held right across the UK, including Thames Water, Airbus, Zurich, and just so many more, Dan. There's loads going on.
Yeah, so don't miss out. But now we're going to be electrifying your brains with some cool electricity facts.
Wow, you're quick off the spark, Dan.
Just shows I'm always switched on.
Oh, yeah, I see where you're going now. So we're on a roll, but electricity is really everywhere, isn't it? It's powering your computer, your tablet, so you can watch our Engineering Open House Day live. It's powering the lights here in the studio. It's even like powering our cars and on driveways outside. They plug them in now and they're run by electricity, and it helps to run hospitals, and it's even apparently within our bodies everywhere.
Yeah, did you know the human body conducts electricity? Nerves in our bodies carry small electrical currents, and these currents send messages to different parts of our body. So electricity is really everywhere.
I saw something the other day where they're now trying to charge mobile phones overnight using electricity that is in your fingertips and the conductivity through sweat. That's just bonkers. It can charge your phone in like 10 hours.
And who's doing it? Engineers.
Engineers, absolutely everything's engineered, isn't it? So let's head over to General Electric now to meet some of the engineers from General Electric who are using pioneering technologies to build a world that works, improving the lives of billions.
Hi everyone, my name is Victoria and I'm a fourth year apprentice at GE Caledonian. Somebody I heard called Connell had asked what is it like working with electricity? And here at GE Caledonian, our main job is to make sure that aircraft engines can fly again. Aircraft engines are those things that circle underneath the wings on the airplane. And your question was regarding how was it like working with electricity. Well, to be honest, as long as you study well and you learn everything, it's really easy because we've actually figured out exactly what you have to do to make something work. So it's really exciting, and if you ever consider it, you will absolutely love it. So somebody has asked a really cool question named Lola regarding how do we make all our inventions? Well, to be very honest with you, I don't make anything. However, I fix aircraft engines. Usually when an engine comes in, it will take us roughly 2 to 3 months to make sure that it's been fully fixed and it is good to go back on the airplane. Thank you.
So another really great question here is, how do you not get electric shocks when you're working with light bulbs? This is a really interesting question actually, from someone who is very sensibly thinking about safety, which is really, really important, and definitely something that GE take really seriously. Obviously we want to avoid electric shocks when we're working with light bulbs, but also if we're working with any kind of product that has lots of electric current running through it. A lot of our products at GE would actually be included in that. So, if you're working with electricity at home, probably one of the biggest ways to avoid getting a shock would be to keep any water far, far away. Water can be conductive, which means that electricity can pass through it. And obviously it's really tricky to control where that water is going to go. So that would definitely be a big one, keeping things dry. Actually, part of my job at the moment is to kind of think about all the ways that something could fail or it could cause harm, like whilst we're designing it. So this question is actually a really good example of that. If you're kind of thinking about those things ahead of time before they happen, we can make sure that we sort of build in sort of safety protective features into the product before it goes out into the world to make sure that those kind of failures don't happen and that people are kept safe. So maybe whoever asked this question is a future reliability engineer.
So Lily Boot asks a brilliant question, which is, how did Thomas Edison design and create the light bulb? And I think simple answer is patience and determination and experimenting. So he made thousands of light bulbs before he actually made the one that burned for 2 hours. And so a glass bulb, which he blew himself in the shed next door to his lab, and then he tried the filament inside the bulb. He tried different materials and burned different ones. So he even tried composite vegetables from all over the world. People sent them from tropical forests and the other side of the world from where he was in America, and eventually got the right material, which was metal, to burn long enough for 2 hours of his first bulb. But now they last for years, but that's just through continually experimenting and changing and trying different things. So a massive amount of patience and determination, I think, is what got him to design the bulb.
Wow, Dan, that was really cool, wasn't it? I mean, it's amazing how one organisation can be trying to do so much for the planet.
I know, yeah, it's amazing, isn't it? And from generating electricity to using electricity to generate happier, healthier lives. Our next guest is Shruk El-Attar, electronic engineer at LV, and was awarded the IET's Women Engineering Society Prize. She's brilliant. I love Shruk. She engineers smart tech that improves the lives of cis women and trans men whilst breaking down barriers and smashing taboo. She's so good at that. She wanted to become an engineer from when she started realising that people on TV weren't these tiny little people living inside it.
Yeah, I mean, that's absolutely right. I'm not living in your TV or computer, but I'm streamed to you via electricity and data all the way from London here in Savoy Place.
That would be really cool, though, wouldn't it, if they were sort of little tiny people.
Yeah.
And to Shruk, electronics was magic, and she dreamt of the day that she'd become the magician. And her childhood dreams have come true.
Shruk previously worked with surgeons operating on the eye, which is, or some people might be a bit squeamish, on an IoT technology, so Internet of Things technology at Intel, and at Fujitsu as well in Kawasaki. So let's have a little look at a video, Dan, all about Shruk.
One of my earliest memories was realizing that the people on my TV are not actually tiny little people living inside it. I wanted to be able to create electronics. I wanted to be able to create this magic. And now I work for Renishaw as an electronics design engineer. I design circuits for things like massive robots that provide measurement for the aerospace industry, all the way to designing circuits for small, tiny encoders that can measure to a nanometer. That's 60,000 times smaller than a single hair. I came to this country as a refugee child. That meant that I was actually not allowed to study engineering at university for many years. But I campaigned with Student Action for Refugees, and we won the right to study at more than 60 universities across the country, and we're still winning more. I want to honour every little girl who found herself a refugee overnight and then was told that she can't be a mathematician, she can't be a scientist or an engineer because she fled war, she fled torture, she fled persecution. It's really important for me to have more diverse role models in STEM. We need to change the notion of what it is to look like an engineer, and we can only do this by encouraging more women, more girls, and more diverse people into STEM.
Well, as you can hear, she's here today with us live in the studio. Welcome. Brilliant. So, Shrew, I'm brilliant. How are you? You had a good journey down and everything?
Yes, it's been a while since I got on a train. I actually kind of missed it.
It's been fantastic coming back to the studio, hasn't it? Absolutely brilliant. Obviously, we're all keeping our distance, but we are here in a studio live. So can you explain, Shrew, to people at home and all the young people out there what you do as an electronic engineer?
Yeah, so I work at LV as an electronic engineer, and I make all sorts of circuits. I've got some circuits with me here today. So you might have seen sort of a PCB before, printed circuit boards before. Do you want to know how it works?
Just a little bit, that'd be
great, yeah. Do you want to make your own?
Oh, there's no way.
Yeah.
Look how fat my fingers are. There's no chance.
TV, come on.
So I've got an easy way to make a circuit on paper.
Wow.
Yes.
Go on then, yes, on paper.
Okay, so I've got some conductive ink here. Would you? Yes.
Can I do it too?
Yes. Would you like?
Oh, yeah. Just come a little bit closer. We'll be fine. We'll be fine. Conductive pen.
Conductive pen.
And we mean conductive like for electricity, not sort of, you know.
Yes.
Conductive pen. Yeah, I was going to say it's a very good conductive pen. That marvelous.
I'm sure that would be marvelous too. And I have got my Girl Power notebook.
Oh, this is awesome.
Yeah.
Am I allowed? Is that okay?
Go on, just this time.
So what we're going to do, I'm just going to describe it a little bit. So here, can you see how tiny that component is?
Yes.
That's an LED.
Right.
That's going to emit some light.
It's not really going to emit like that.
It's going to emit some light,
Really?
Mark. It's going to emit some light.
Show it up there to camera 2 if you wouldn't mind. That'd be brilliant.
So that's an LED over there, and that's a resistor.
Wow, this is going to be fantastic.
So can you work out why we need a resistor before the LED?
Go on, Mark. You can do it.
To stop the light working.
Actually, kind of close. It's to limit the current going to the light, because if you put too much current, it can go boom.
Got you.
We don't want this to go boom, do we?
And why doesn't the resistor go boom? Am I going too into this now? I don't know much about
So the resistor can also go boom if you choose the wrong resistor. So we are making sure that there is enough power that this resistor is rated at for the power line that we are drawing. So I'm going to get you to draw some power lines. Are you ready for that?
Oh, yeah.
Yeah? Okay.
Right.
So,
does it have to be special paper or can it be any paper?
It can be any paper.
Wow.
Special pen.
It has to be a special pen, a conductive pen. This one is called Circuit Scribe, and you can buy it from Amazon. Yeah? Shall we go for it? All right. This is your Girl Power paper.
Thank you very much.
And this
I know what's on your Christmas list.
Oh,
now,
this is absolutely on my Christmas list. I mean,
and this is your
right, we can
fantastic.
draw
So
anything.
you've drawn already on there a. There's like that's an LED, is it?
Yes.
And that's the resistor.
Yes, so what we need to do is we need to complete the circuit here. You can either draw a line or you can draw a heart, a squiggle, as long as it connects to each other. Shall we do it?
Yeah.
All right, what are you going to draw?
I'm going to draw.
Mine started off as a heart, but it's gone a bit wrong.
I'm going to draw sort of a heart too.
Oh, yeah.
So make sure the line is nice and thick, because we want it to be the easiest path for electricity
so which
to
camera
go
should I
through.
go on? This one over here. Do you want me to? Should I come a bit closer?
Mine's like half a butterfly sort of thing.
Oh, that's so cute.
What we got there? Oh, let me just check. Hang on, which one's the LED? Is it that one?
Yes, so the top
Both.
one is the LED.
I haven't got very good eyes. That's the LED there. That's the LED there. That's the resistor, and I've drawn a wiggly line, and I think we need some electricity now at that end.
Yeah, we need
that.
So how do we provide that electricity?
Yes, exactly.
Right,
Yes.
come on in.
So I've got some batteries for you.
Little
Okay,
tiny batteries.
let
Now, you
me
must
try
be
mine
very
first.
careful if you're trying this at home. I'm just going to put out a warning now. These little batteries can be very, very dangerous if you're a small child, isn't that right? So if you're doing this at home, make sure you get an adult to help you, and those little batteries must be put away safe afterwards, because if you swallow them, they can cause all sorts of problems.
Exactly.
Good. Just
So-
got that.
We're going to put the negative terminal here
Yes.
at the end of the diode. So there.
Right.
And then I am going to
Wow, it actually
make
lights
a
up.
complete circuit.
that.
So
That's
there I go.
bonkers. Oh, can I show them up there?
Yeah, you use it.
Right, here we go. So you've got your so you put your little batteries on the big fat one.
Yeah.
And then you bend that over. Oh, it's not going to work for me.
So the
is it?
negative terminal on the diode and on the LED.
Go on, Mark, you can do it.
Go on, Mark, I believe in you.
Come on.
Oh no, you shouldn't have. no, it's.
You know what? That's my favourite part when I make circuits is working out what went wrong.
I think it's my fingers have gone wrong. That's what it is. No, nothing from me.
Okay,
nothing
let
from me.
me-
But it did work over here. It did work over here. I promise you.
Let me do it.
Go on. Shroot's going to jump up
Come
and
on,
show you all
Shroot.
this.
Okay, so I am putting that terminal there.
I was really excited then as well. Actually,
You nearly did it.
I know. It's
Oh,
like this was
sorry.
my whole.
I think
this was
I think it's
many
really
years
up
at
again.
school, just shaking heads at me.
Ooh.
Mr. Klube, he'll remember.
Mine stopped working too.
Come
So
on.
You did see it light up, didn't you?
Did see it light up.
That's it.
There is
Fantastic.
one
So
here as
literally, you
well.
can do all that with a pen, piece
Yes.
of paper, and some things. So you started off there when we were asking about femtech and all those things. What does that mean? And what's some of the things you've brought in with us?
Sure, so this is a breast pump that LV makes, that my company makes, and this is the sort of thing that I'd be working on. So I could be designing a PCB, a printed circuit board that looks just like this.
Wow.
So that's very similar to what we drew here.
Yes.
There are some tracks, and they are connected to each other. But actually what's really cool about that is it can be multiple layers. So even though you can see one layer at the top and one layer at the bottom, there are layers in between of tracks. Yes, exactly. But yeah, it's not as hard as people think it is. It really isn't.
And what got you into all this, Shrew? When did you become sort of so interested in electronic engineering and everything that you're so excited about?
Well, honestly, it was literally just figuring out that people on my TV didn't live inside it, and then it made me bonkers about electronics. I used to take all of my electronics apart. I took apart my mum's mobile phone and
Did it
everything.
work
Yeah.
afterwards?
It did not work.
Oh, I did that with
how
my
did
dad
that
as well.
go
I used to
come
take
out?
all my stuff apart and he could never fix it afterwards. He'd be
She
like,
was not
I
happy.
can imagine, yes. If you had to pick one of the projects you've worked on, like the best project you've worked on, which one would it be?
Oh, the best projects that I worked on. I love all the technologies that I make right now. Probably my master's project was my favorite one. So I made a machine that can detect things like cancer based on electron quantum spin. And I miniaturized a machine that usually fills a whole room. So if you think of an MRI machine, it's
Yes.
quite big, right?
Yep.
So it's something similar in size and normally cost hundreds of thousands of pounds, if not millions of pounds. What I made does the same thing, but it's about this size and cost about £300 to make.
wow.
Yes.
That makes
must
it
be-
so accessible for people as well, doesn't it?
that'd be
You know, it's brilliant.
Fantastic. And you've also worked with surgeons operating on the eye, haven't you? I mean, are you squeamish for a start? Did you have to watch operations on eyes?
Actually, I didn't have to do a lot of watching the operations themselves. I spoke with the surgeons, and honestly, that was one of my first ever electronic engineering projects, and I was terrified. I thought I couldn't do it, and I spoke with them, and really when I simplified the problem, so what they wanted to do is they have a probe that they use to do the surgery. They wanted to make sure that the surgeon's hands are not too shaky. They wanted to make sure they're not nervous, and they wanted to make sure that they finish the operation in time. So all I had to do is put a vibration sensor, an accelerometer. If you don't know what an accelerometer is, it's how your phone knows if it's in portrait mode or in landscape mode. Also, a sensor that detects sweat called galvanic skin response, and then a time logger. Literally, when you simplify it to these things, it's not as terrifying as you might think.
And that's really what engineering is, isn't it?
Yeah,
it's like taking
yeah.
a problem and finding a solution and then simplifying it to make it cost effective.
Yeah, and there's so many different applications. You know, you could take those 3 things that you said there and just apply it to so many different things, not just eye technology as well.
Yeah, absolutely.
Yeah.
And it's really creative. This is why I brought the pens here, because I want people to be able to draw, you know, a flower and hearts and a house and make a whole village on their paper. And you can do that at home.
That is brilliant.
This is going to be a winner with my daughter.
Yeah, absolutely.
Can I keep this now?
Yeah.
I can't give it back to you now.
Absolutely.
So.
Well, I've touched it now as well, so we can't sterilise that. That's that now. But you won the IET's WES Prize, the Women Engineering Society Award, part of the IET's YWE. And what did that mean to win the award? That must have been amazing.
It was everything that just made me have so much more confidence in my own skills and made me feel like I am the engineer that I see myself as. But it was just an amazing experience, and I met so many wonderful people during that competition as well.
Yeah.
But some of them are here today, aren't they?
Yes.
Yeah.
And it's the first time you've actually met them in person as well, isn't it? Because we had to do so much virtually this year, haven't we?
But how did that happen, though? Doing all of the virtual stuff happened because of engineering, right?
Exactly.
We have the engineering to do all of this virtual conferences and competitions. It was amazing.
Live studios,
Live
going out live.
studios.
All amazing.
Exactly. No, it's brilliant. I've got we've just been using resistors here. Can I tell you my joke?
Yeah.
Go on.
I've got,
is this a
I've
good one?
got
Is it worth
It's
building
an engineering
up for?
joke. You
All
ready?
right, come on then. We're waiting for this, aren't we now?
Wait.
Why did Mr. Ohm marry Mrs. Ohm?
I don't know. Why did
Why?
Mr. Ohm marry Mrs. Ohm?
Because he couldn't resist her.
Ah! Like that one. Love it. Brilliant. Oh, we've got a long way to go. It's going to be a long day. I can
It's
see
only
it
the
now.
second hour. Oh, no.
Well, that is amazing. Absolutely amazing stuff
amazing.
you've done, isn't it?
Thank you so much, Brooke. It's been brilliant. And it just shows, doesn't it, how amazing electricity is and how it's just at the centre of everything we do.
Thank you.
Well, you've proved that electricity really is just everywhere. And we can't imagine the world without electricity now, can we?
Really can't. Definitely not. You know, especially when you need to... have you got your stopwatch? Have you got batteries in that?
I have got my stopwatch and I have got my...
Might be time.
Whistle. I think it's time. It's your time to shine. Let's
Oh.
go. Make our way over.
No pressure.
It's the paper plane challenge.
Oh my God. Okay. Oh
Let's
no.
make our way. If you make your way over to the engineering expert area behind there, we'll have a quick look at the leaderboard and remind everyone on the rules to be involved. Let's remind those rules now. So, they're up there on the screen. Don't forget, you need to find an adult to film you to make sure that you get the aeroplane going from A to B in one continuous movement. You've got 60 seconds. And they're the rest of the rules on the screen. If you send all those into hashtag EOHD paperplane and make sure you put your child's name and age on the top of it. So here we are, Shrook. We are now over at the special experts area. You know the rules, I think, don't you? You're going to have 60 seconds from the time I blow my whistle.
No, I have never made a paper.
You've never made a paper airplane. This is going to be absolutely brilliant. So I can't wait.
Look at that.
It's going to go.
That was
far.
Sophie, our aerospace
aerospace
engineer. And that's the other aerospace engineer down the other end. So you can see there the difference in rocket thrusters they put on those. So Shrook, this is as an electrical engineer, electronics engineer. You haven't got any wires here, but you could decorate a few lines on there at the end.
Yeah, I could put some.
But the
some LEDs on there.
least amount of resistance the plane will go the further. You see what the resistance?
Yeah.
No, never mind. I'm trying my hardest here. Right. So let's count her in then in 5, 4, 3, 2, 1.
Okay.
And
All right, let's do it.
Have you? Oh, you're literally just going for a backwards fold.
Do
there.
it.
Did you
Oh,
see
I
the
like
backwards
it.
fold?
Yeah.
That's incredible.
We've all
You
got our
must have
different
made this
reasons.
before, Shrook.
No, I'm.
You're copying those up
looking
there.
at
Well,
that.
you've only got 45 seconds left, so you know.
How is that? What are they doing?
Oh my word! This is gold
This
dust.
is not going to work.
Do you know what? I bet this will probably go the furthest.
Yeah, a bit of foldage anyway. Yeah, we got 30 seconds.
No,
30 seconds. Don't
Oh,
panic.
30
You're right. You've got
seconds
30
is
seconds.
fine. Oh, 30
That's an
seconds is
age.
nice.
You're only halfway through.
Yeah, that's looking pretty interesting.
Fold it. Yeah, fold
maybe
it
a bit
in
of
the middle, I
foldage.
think.
Bit of foldage. Right.
Yes. You have advice.
And maybe pull the sides down a bit there. That could do it. That could do it.
you
We've
think?
got 20 seconds. Got some pens here. Got some pens. Would you like to maybe colour it in a bit? That might help.
Okay. Oh, okay. Yes.
Yeah, a bit of colouring. I've got 10 seconds for colours. Lovely. She's writing her name on there just so we know when it's gone right through the other side of the
Is
door. Awesome. Oh, 5, 4, 3, 2, 1.
Do I throw it from here?
Whistle's gone again.
Okay,
Right.
all right, let's do it.
Thank gosh for the clacks. And now then, okay, you can run up. Oh, hang on. You can do a run up, but if your foot goes over the line before you let go of the plane, that will be a DNF.
Oh
Did
my
not
God.
fly.
Okay.
Okay, so on the count of 3, then everybody. 3,
No.
2, 1. Yo, throw it! it's just there.
Thank you very much.
Thank you very much, India. She's brought your. It's actually
Brilliant.
It's actually less distance than the length of the plane, which is.
Can we have like a
Is that
first
right there?
and
Is it-
last
is it-
prize?
Brilliant.
Yeah, we need like the wooden spoon.
Right. Well,
type
so
prize.
Shriek, I'm gonna measure now with my special
I don't think
electronic
we need
measure.
to measure.
Yeah. Look, it's a laser measure. 0.4 of a metre.
No, we don't say that.
Is that right? That doesn't.
Yeah.
It might not even. This might not measure that length. Let's
Yeah, I
try
reckon
again.
that's just under half a metre.
Yeah.
You reckon?
Yeah.
0.402 of a metre. Right. Well, we'll write that up for you. Hang on a second.
Sure, I haven't been yet.
Yeah.
So I think I'm going to get negative.
I don't
Zero,
think
It's
you
going to
can.
go backwards,
I
mine.
don't think. Oh,
meters.
maybe if you do
Yeah,
that.
fly backwards.
Okay. We'll put that one up here. Look, and now we're going to put because it looks like a better leaderboard when they're up there. Wow, well done, Shriek. So, do you think your tactics worked well there?
I'm going to go with no.
Yeah, I don't think we can explain it any other way, can we? Really? But it was a valiant effort.
It was.
Thank you
And it
so
was
much.
Brilliant. It's so lovely to see you, Shuk. Thank you so much for joining us.
Thank you.
I think
Excellent.
the competition is looking pretty hot on this.
It's
leaderboard.
looking great. I mean,
Stacking up.
I can't quite believe that Mr. World came in and just smashed it to the other end
I
of
know,
the
yeah.
studio. 6.7. Sophie's a little bit unlucky, I think, and Shriek, it just didn't
Brilliant.
get going really. Didn't have that.
It's brilliant.
oomph behind
Electronics engineer.
it. Yeah. So let's go and see what's coming up then, shall we? Let's see what's happening next. Well. Oh, we've got this. It's incredible seeing how electricity's really transformed everything, hasn't it? It's just incredible. So what else is happening? We've got electricity. We've been talking a lot about that. Yeah, all the cars have been run by electricity now. We've plugged them in and everything else that's going on. But I think really now what we should do is have a look perhaps for a bit of social media. Let's have a few shout outs. Have we got any social media for us? Yeah, we got Diggity down there. I've got a day off, so like a proper nerd, I've saved up Sarah Gilbert and Catherine Green's Book of the Week on BBC Radio 5. I'm enjoying watching the IET's Open House Day. Fantastic.
Excellent.
That's brilliant. Who else we got? Well, as we might Maddie Mo there. Some of you might remember this fun water wheel build. Let's go live. Well, today we teamed up with the hashtag IET Engineering Open House Day to show you how to make one. Join me, Greg Foot, and watch the host of experts from 10. Brilliant.
Brilliant.
Thanks, guys.
Absolutely.
Who's this one from? Can you get that one? Go on, Dan, you get this one.
We're so excited to be collaborating with, it's a Science and Industry Museum in Manchester, woohoo, to help young people explore careers in engineering. Yay.
Oh, and there's one from the IET Open House Day is here, way! And we're all so excited to welcome you all. And here is our Chief Engineer's attempt detail on how to enter here. Yes, it was. That was Sir Julian there.
Ah,
doing his
brilliant.
paper
Yay.
airplane.
Excellent.
Brilliant. Brilliant. So what are we going to go next? So, it is incredible to see how electricity has transformed everything from the healthcare industry and everything else, and it's making such an impact across everything we do. Our cars being run by electricity, everything. You can plug them into a charge point, and you can take the electricity from the grid, and then you can literally recharge all those batteries just on your driveway. And that turns the wheels, I suppose. I mean, it's electrical motors, amazing.
Yeah.
And they even say that with the right equipment one day, an electric car could actually power your home. I think that's starting now. I think in America, Tesla have done this thing where you can plug your car in, and if you have a power cut, you can power your home
So it comes
the
back.
opposite way round.
So good.
Just phenomenal.
I know, and they're becoming so popular now, aren't they? In fact, in 2019, a new electric car was registered every 9 minutes in the UK. Wow. And you may have spotted the special green number plates on electric cars when you go out and about. No. If you haven't, keep your eyes peeled. It is a great, if you're going on a long journey, I Spy.
Have they really got, do
Yeah.
they have to have? Do all of them
Yeah,
have?
green Green cars,
I've
green
never
number
seen
plates.
that.
Yeah, it's a good
So,
idea.
and we've seen electric cars take to the motorsport world with Formula E. They wanted to show sustainable energy was really capable of driving electric vehicles to the fore, and that really is a race for greener, faster future, isn't it?
Yeah, absolutely. And speaking of recharging, I think Mark needs to recharge while we visit the next organisation.
Oh, yes, good thinking, Dan. I hope there's some cake around. While some of our cars may need electricity recharge, I like cake and sandwiches. That's my favourite. So I think my low fuel tank lights come on.
Now, Green Power Education Trust have been our IET education partners for 10 years. And they're a UK-based charity who challenges young people to design, build and race electric cars. Over 700 teams throughout the UK take part in their regional events, with more than 10,000 students every year that take part, all the way from primary school up to university. And today, they're going to show us how they make their cars ready for racing. And if you head over to the Media Hub, you can see the full video where they show you how you make a mini Goblin. That's a mini car model with just some card or paper you find at home. Let's go see how they race electric.
Wow.
The bodywork of a car is a challenging thing to design. Not only is it responsible for the aesthetics, the way the car looks, but it's also a key component to the car's safety. If you accidentally hit something, it's your first line of defence. So that begs the question, where do we begin when designing it? Now, in industry, it would cost a lot of money to trial out every single design that they come up with in their minds, which is why we use models. Now, you can see some models over my shoulder, but actually earlier I went away and I built 3 little Goblin models of my own. And you can see with these 3 designs here, I've tried out some very different concepts. And I've been able to do that because models are something that we can produce very quick and also very cheap, which is why they're loved by industry, because they can save money on their research and development before they commit to the final model.
Hey, that's quite a different scale, isn't it? Little model, full-size car. I guess now, having seen how these panels work on this model, I can actually get on with making the panels to do the bodywork for our full-size car. So let's get on with that. Now, when it comes to actually making our bodywork panels, I've got a little tip here that can be really useful. What I've done is I've actually taped together some pieces of paper to form a long strip that's going to go round and form what I'm going to call our front bumper. And you can see on our little model here that we've got that strip around there. So what I'm doing is I'm going to use this paper. I'm just going to tack it on to the chassis here. And what I'm doing is I'm checking size. So I can see here it's a little bit too tall, this piece of paper. I'm coming from the bottom of the chassis. So what I'm going to do is going to put a little mark here and here as well at the top of where these supports fold over. Now, and I know I've actually got the right length, I've got my bumper that wraps around, I've got my height that I've worked out here. I can take this off the car carefully and I can go and cut a piece of the actual material I'm going to use for my bodywork, which is going to be corrugated plastic. So it's going to look white again, but it's a bit more rigid and a bit more solid than just a piece of paper, which isn't the best. So now I'm going to go and do that, and I'll come back in a moment. Having taken my paper template, I've been away and I've cut out some of my bodywork material. Always recommend that actually an adult does that cutting because it involves sharp blades and we don't want to be injuring ourselves. So I've now, on that piece of Correx is the name, it's corrugated plastic in this case. I've marked a little centre point here. That's the centre along the length, because then I'm going to line that up with my centre position on the car. I've also then marked 2 other positions, and that is these corners here, where it needs a little bit of a fold to get round the corner. So to aid that fold, I've put a score mark in here with a blunt tool, and that means I can actually create a nice straight line bend at each end. And that was done by sort of holding the panel to the car, and you can see now that actually now I've done that, I can actually hold it in place and it fits really nicely. Now I've actually got to attach it to the car, so what I'm going to do is I'm going to put some marks on my plastic that match up with the holes in the front and sides of the car, and then I use some cable ties to hold those together. So that's the next step. Let's get that marked up, and we can get it actually attached to the car. We've now got our side panel that we trial fitted first of all, fully secured with cable ties along top and bottom and at the front. We've also done the same thing on this side, which is a repeat of that side. And now I'm ready to think about cutting my bonnet, as we can see on our model here. So I've got a paper template on now, which I've just tacked on with a couple of bits of sticky tape on the dash panel here. So by taking that over, I can mark it where it folds over the edges here. I can cut that line. I've marked around the front, around the top of the bumper line with a marker pen, and back up this side. So now I can actually go and get that cut out and then fit it to the car. So going back to our model car, we've got our bonnet on here. We've now, having done our template and cut around that template, attached our bonnet to the real car. And that is our bodywork.
Hello, me again. Before you go, I just wanted to show you some pictures of bodyworks that have actually made it to the racetrack. Let's check them out. Bamboo! We talked about it, and there it is, being used on a Goblin car. What about this next one? What an amazing willow design. I don't know how they managed to get it to grow around the car. I mean, that looks absolutely amazing. This next one is really cool. Bottle tops! It looks a bit weird on the model, but people actually had the idea to do bottle tops on their car. And again, bamboo for the front grille. What a brilliant design. Ah! So sorry, that one scared me. Really imposing, scary car. You really can do any design you want. Just like this cute little puppy. Not so scary as the last one. What about this very bright flamingo? Obviously, you're not going to miss that on the racetrack. And on top of all of that, you could even have your favourite character from a film, a book, or maybe a cartoon. Your imagination really is the limit. There are only 2 rules that you need to consider when designing a car. Rule number 1, it must fully enclose the driver. The driver cannot be able to escape the car through any other means than from out of the cockpit. And number 2, there cannot be any sharp edges. It needs to be smooth to the touch, and that way no one will accidentally get hurt when performing a driver change. If you follow those 2 rules, you should be good to go racing when you show up on the day. If you found this video helpful and you had a lot of fun, please leave us a like and subscribe. It really helps us out. I can't wait to see your own designs popping up on social media. Make sure to tag Green Power in any posts you make. But other than that, I can't wait to see you at the racetrack. And until then, take care.
Great work. Thank you to Green Power for showing us how to build these cars. I think my favourite one was the flamingo. How about you?
Oh, definitely. I love the flamingo. That was cool. It was really, I mean, just the colours and everything. But I did like some of the others too as well.
Yeah.
And to be honest with you, I made one while we were following along. I mean, I didn't make it all. I finished it off, to be fair. But you can literally make them at home. And look at that. That's really cool.
That looks so good. I'm very impressed. You should get yourself signed up to the Green Power events.
I'd love to. I've been down to watch one, but I think I'm just over their age limit now, Dan, to be fair.
Just a tiny bit. If you want to see more from our IET education partners, then head over to the education website, where you'll find loads of activities and resources, and you can even get yourself one of these goodie bags. They are brilliant. And this one is for primary. This is a primary STEM pack. They are so brilliant. Have you got the secondary one?
I've got the secondary one.
Yeah, so primary
brilliant.
and secondary.
Loads of stuff
They are
in there.
brilliant. I absolutely love them.
Yeah.
Let's see what everyone at home is loving this engineering open house day, and maybe get some paper plane distances up on our leaderboard as well. Let's see.
There you go. IET open house days. In the future, we could be living underwater. Could we be living underwater?
Ooh.
That's a great question for later.
Yeah,
Got
good
one more,
engineering
I think, coming
one.
in. Let's have a look.
The IET 150th birthday celebrations rocket build. That is a great rocket. I love that.
Even managed to get the 150th birthday celebrations in there as well.
Excellent. Now, thanks to everyone at home, and we really had so much fun so far, and the fun does not stop here. We have 3 more episodes of STEM fun for you at home. So make sure you've submitted your questions via social media using the hashtag IET Open House for me to answer in the next episode. I am a little bit nervous about this. And we'll even get some post-lunch snacks. Plus, I know, yeah, good. We like snacks. Plus, remember, our Media Hub has so many live events happening right now, so head over to there too. And don't worry, all of our events will be available on demand over the 6 weeks holidays.
But now I think it's a really, really exciting time. I think it's time we had some experiments, don't you, Dan?
Oh, yeah.
Now, this could get a little bit confusing because we've got Danielle George Dan, and we've also got Dangerous Dan from Mad Science. He's here to lead us on a magical mystery tour of air and pressure. We'll witness some amazing demonstrations such as gravity-defying floating balls.
They're going to show how Bernoulli's principle creates enough lift to make a jumbo jet fly, or how air pressure can be used to launch a hot air balloon with vacuums, vortexes and vibrations. How exciting does this sound?
It really does. It's been so exciting. I can't wait for this
Yeah.
moment. So welcome to Dangerous Dan from Mad Science East. Whey! Wow, I've got to come over, haven't I?
Yes, absolutely.
Brilliant.
Come
Now,
on over. Come on
just
over.
before we start, if anybody's noticed, I've had to move the aeroplanes onto the stage area because Dangerous Dan's dangerous, so we don't want those getting trampled. But we will put them back in the right place with our little measure and everything. It's all the rules are fine. We've got adjudicators. So, Dangerous Dan, good to see you here in the
Good to see you
studio.
too.
What are you going to do for us?
Well, we're going to talk all about air today and why it's so important.
Brilliant.
Yeah.
And are you going to be doing some crazy experiments? So what do we need to do first? What do you want us to get?
Well,
start with air.
Exactly.
Right?
I think we need to know how much of it there is.
What, just in here or everywhere?
Everywhere. How much of it specifically is on top of your head pushing down? How much pressure there is? So in order to figure that out, we need to know how far away the edge of space is.
Yes.
Because that is where the air essentially stops.
So that was like 100 kilometres-ish, wasn't it? 80 kilometres?
I would say
something like that?
62-ish miles.
Yes, that's what they said, 100. Yeah, that's about right. Yeah,
I'm old Imperial.
Oh,
I
you're
don't know the
Imperial.
math check,
Yeah.
unfortunately. Sorry about that. So, yeah.
Look at me
it's
up with the...
Terrible. So all of that air is on top of your head, pushing down at the same time. Now, would you say that weighs anything?
Well, it doesn't feel like it weighs anything. I mean, I've got a bad back, but it's, I don't think it's the air.
It doesn't feel like it weighs anything at all, but in fact, there is 2.5 tons of pressure pushing down in your head.
No.
Yep,
That's like 2 family cars.
Or 1 African elephant.
Oh,
right now.
I'd rather have 2
sat on
family
your
cars
head.
than that.
That's why all your hair's fallen out, Mark.
Oh dear.
Oh, there was no need for that.
So why do you think you're not squished like a pancake? Why are you not a
'Cause
jelly
I'm
on the
so
floor?
strong and muscular and fit.
That might be part of it, but what about me?
Oh, yeah, no, that is true. Why aren't you squashed and fit? I mean, I know why I'm not.
So the reason is, take a nice deep breath. You are full of air. And I can prove this with
I
this
wondered where you were going
lovely
then.
bottle here. This represents us right now, full of air. So now, if I was to take out all of the air, what is going to happen to the bottle? Are you ready?
Oh, it squishes.
Straight away, it is crushed. And it is crushed by all of that air pressure around you. Now, even though the air around us is slow moving, it still has that 2.5 tons
So it's
of
not
pressure.
crushed by sucking the air out. It's crushed by the other air trying to get in effectively through the edge of the bottle.
We are creating a vacuum in here. So there's no air. And the air doesn't like that. It wants to get into it. And so it crushes it from all the outside
Wow.
possible angles. And now we have this. All you need to do to bring it back to life. And it is full of air again. And now it is a completely fine, okay bottle to use again for later. So
That's amazing.
I think we can use this air to our advantage. So I'm going to introduce you a friend. This is old Peter Ping Pong Ball right here.
Right.
We are going to try and keep him in the air. But we are not going to use the 2.5 tons of pressure. What we're going to use is the opposite of that. We're going to create fast-moving air, and that lowers the pressure. So I have brought with me a lovely hairdryer from home. Let's see if it works.
If it works.
There we go. Nice and dry, perfect. And we are going to take, you're going to take Peter, and you are going to place him on top of the hairdryer.
Okay.
Slowly.
Oh, slowly. Sorry. Slowly. Wow.
Now, at the moment, we have a column of fast-moving air going upwards. But what happens if we tilt the hairdryer?
It'll fall off.
It should fall off,
It
right?
will.
Now you're seeing
Not falling off.
it is staying on.
Well, how's it doing that?
Well, that is an excellent question.
That's a good catch as well.
Thank you very much.
That's all right.
So, at the moment, we created fast-moving air from the hairdryer. That essentially causes low pressure. Now, all around us at the moment, we've already established we've got 2.5 tons of slow-moving, high-pressure air. That means as we turn the hairdryer, whilst that fast-moving air is allowing our ping pong ball to float, all of the slow-moving air is pushing in, trying to get into that column of fast-moving air.
Wow.
Just like it was trying to get into our bottle, it crushed it. Just like that fast-moving air is keeping the slow-moving air in that column.
Wow.
It's amazing. So I think we should add some more stuff.
Yes.
Because we have some balloons. So here, you take a balloon, blow it up for me.
Okay, here
you
we
can
go.
name it as well. I think that one's just about big enough for me.
How big? That big?
That big, little smaller.
Okay. There you go. You want that one?
Perfect. Oh. Try that one.
Mine's.
You're making this look like hard work.
It seems like I think these are different balloons. These ones.
Right. So I've got a small one, a big one, and you've got a medium-sized one. So we're going to try and keep all of them on at the same time. Uh-oh. I don't feel like this is going to go very well. Perfect. You hold on to that one, and I will hold on to this. Actually, you hold on to two.
Oh, no.
And I will put the first one on, and then you are going to put the next ones on, and then we should finish with Peter. Hopefully, we'll have all four in the air. Hopefully.
4? Oh, sorry. I was thinking.
You can do it.
Are we ready?
Come on.
There's one. All right. Add the purple one.
In here.
Yep. 2. Oh, no.
Juggle it. Juggle it.
Go ahead.
Oh.
Put it back on. And now the blue one.
No.
The blue one. We'll put Peter's fine, but you've got to put all the other ones on.
Go on, Mark.
Aim high. That's it. There we go. We've got 2. Can we get third?
Yay!
Quick, the purple one. There we go. The blue one's escaping. The ball's gone.
Like juggling.
We're getting there.
Yes! Brilliant!
Oh, I would say that's about as good as we're going to get. Not too
Excellent.
bad.
I love
pretty
being your
good.
assistant.
Very energetic. So, we managed to get, I would say at one time, 4 objects were on there. But you might have noticed that this is not perfectly spherical. So, Peter's ping pong ball, all of the air goes up and goes around him, and then goes up and around. But
Got you.
unfortunately, your blue one, because it is not quite perfectly
bad.
spherical, it's got this bit here, it does a little wobble.
Yes.
So, to try and get all of them in the air, we would need perfect spheres.
Got you.
But
Different sizes or all the same size?
at different sizes to stack them properly.
Yes, brilliant.
Now, obviously, we're mad science. And you could do this at home if you wanted to, with your own ping pong balls and your own balloon and a hairdryer if you've got one, but we need to do things bigger. So I have brought a slightly bigger hairdryer with me. It's just over here, in the form of my leaf blower. It is pretty big, it's pretty powerful.
I did that before, and look what happened.
You want to try?
No, I've been there once. Not doing that again.
Now, I don't think we should put the ball on there, because it would just fire right into the
Shall I have
ceiling.
it?
But we can bring something bigger. I believe around there you have a slightly bigger ball, just slightly. Perfect. We have our lovely ping pong, our lovely beach ball. And you might have noticed it is perfectly spherical.
Look at that. Woohoo!
So you are going to be in charge of this time. Are you ready? We're going to start low because these ceilings
low.
aren't as high. You ready? 3, 2, 1.
Brilliant.
Good. That's good, right? I mean, you see, all of that high pressure air was keeping our ping pong ball floating all the way, sorry, our beach ball all the way over there.
Wow.
Amazing, right? But why is this useful? It is fun, but at the moment it doesn't seem very useful. So we need to translate it to something a little more
Unless
useful.
you want children on the beach not to be able to get their beach balls.
Oh, you could use that. I think what we need to do is introduce some toilet roll. Yes. Toilet roll is going to show us how we can make things fly. Now, we are going to use that same principle of the high pressure and low pressure air. And this is Bernoulli's principle, which we mentioned earlier. And now this definitely helps us fly. What we're going to do is we're going to blow over the top, creating fast-moving low pressure air. That means underneath we will have slow moving high pressure air. So we should get lift. So normally when you blow on something, you expect it to go in that direction downwards. But because of this Bernoulli's principle, the toilet roll should go up. But I have not got enough breath to keep this going, so I think we should bring back the leaf blower.
Yes.
Now, here we go. I will hold this. We are going to put our fast-moving air over the top and see how much lift we can get on our toilet roll. Are you ready? 3, 2, 1. Amazing. Well, we've got plenty of toilet rolls. Do you want to see it again?
Yeah, let's do it again. Let's do it
again.
Leave that. I'll leave it for a minute. Right.
Have time. I think I'll hold it this time. Do you want to have the leaf blower?
Can I have the leaf
Of course
blower?
you can.
Where's the on button?
Right there.
This one.
Right. Have you got a victim that we can cover
Victim,
in toilet
that
roll?
one there. Yeah.
Right, perfect.
Tom,
go for
camera
it. Here
one.
we go.
Which way?
Just any way.
Anyway.
Any way.
Go for Adam. John, go for John. Back to Tom.
Thank you very much.
Brilliant.
It's fun every time.
It works, doesn't it? That's brilliant.
Great.
That is brilliant. Well, wasn't that amazing?
That is so good.
Wouldn't you?
Absolutely brilliant.
We could
That's
do that
why
all
air's
day,
important.
couldn't we? Well, Dan, that is absolutely. We're going to have to tidy the studio up a bit now, aren't we? Got a little bit of a problem up there.
Sorry about your life.
But thank you so much for coming in, Dan.
very, very
We're
welcome.
absolutely brilliant. Thank you so much. Back to you, Dan. I'll tidy up.
Good. That was brilliant, Dan. Thank you so much. Well, that has brought us to the end of this section of Engineering Open House Show. All about electricity and the end of my co-hosting. Boo. I've had such a brilliant time,
already?
Mark. Yeah. And we've learned so much from all the amazing guests we've had, haven't we?
Well, it's been absolutely brilliant to have you as my sidekick and obviously president of the IET to learn about electricity. But don't worry, you won't be away for too long, will you, Dan? As we're going to get you back on for your Ask Dan section, which is coming up in our next episode, as well as the moment, the whole of this wonderful institution we've been waiting for, your paper plane challenge.
I know, I'm very, very nervous. Have I got time to practice?
No time to practice. You're not allowed to practice. So no cheating, not in between. Oh, I've got one as well. I just thought of one. What do you call a flower that runs on electricity?
I don't know. What do you call a flower that runs on electricity?
A power plant.
Oh my goodness.
Well, there's plenty more of those jokes where that came from. So in our next episode, we'll be looking at all things transport. So really stick around for that. But before that, Andrew Smith is going to show us some more of his amazing baconeering.
Let's get started. So when I heard it was the IT's 150th birthday, every birthday needs a birthday cake, right? But I didn't want to just use normal candles. I wanted to elevate it, put a bit of the engineering and technology into the IET cake. So out with the candles, and in we're bringing LEDs. Now, this is probably one of the toughest problems I've had to solve in the kitchen. A bit like a lot of engineering, I broke it down into different components. So first of all, what was my design brief? Well, I want my electric birthday cake to behave the same way as a normal birthday cake. So I want to be able to come over, extinguish or turn off the lights, and then cut straight into the cake. I don't want to have to unplug lots of things and lift things away. So that's kind of my design brief. But how do I convert something like this into something that I can actually eat? Well, there's 3 problems to overcome. And the first one was obviously, I don't want to poison anybody. There's a lot of different materials in here which wouldn't be good for my digestive system. So is there something that is a good conductor that is safe to eat? And it turns out, yes, there is. Edible gold goes back to ancient Egyptian times. 5,000 years ago it was used. And back then it was thought to have some health or healing properties and was also a display of wealth. Now, I hate to break it to you. Unfortunately, gold doesn't have any health properties because it's totally inert. So it's completely safe to eat. It passes straight through your digestive system as long as it's pure enough. So if you are going to eat gold, it's not something you say every day, then it needs to be 23 to 24 karat gold. So that's my material. and it's a wonderful conductor. Lots of HDMI connectors that you might have at home are often gold plated because it's a great conductor of both electricity and heat. So gold's the way to go. My second problem is I need that gold to be in a format that I can work with and move and bend to my will. And that's where gold leaf comes in. Now, if you're in the cake decorating business or fancy cocktails or Michelin star restaurants, fine dining contains a lot of gold leaf, and it is really, really thin. I'll show you a close-up of this. It's about 120 times thinner than a human hair, 0.5 microns, which is amazing because it's so malleable, but makes it a little bit difficult to work with. So I've got to have some way of holding it together in a useful wire, because if I try to do this by hand, I'm not going to get anywhere. It's just too light. So effectively what I'm doing is I'm creating an inside-out wire. Usually with a wire, you've got your conductor on the inside, insulated on the outside. In this case, my conductor is going to be the exterior bit of the wire, my edible gold leaf, and I need an insulator to separate it from other potentially conducting parts of the cake, like my icing. So how do I do that? Strawberry pencils. They fulfill my requirements. They're flexible, they've got a nice flat side, and they're slightly tacky, which means I can transfer the gold leaf on directly and I can make some edible cables. So I'm going to show you how to do this right now. So let's come over here, and I've got my gold leaf and I've got some of my strawberry pencils. Now you want to do this in a real draft-free environment, because even a wisp of wind will carry your gold leaf away. So take your time, get ready, and the easiest way to do it is lift up the side and then immediately press down with your strawberry pencil and then just roll it like that. And then I'm going to get through quite a few bits of gold leaf here, but you want to make sure that they overlap so you've got a continuous connection. And again, it's a little bit of a fiddly job, but take your time. So I'm not going to poison myself, check. I've got my edible conductor in a format I can work with, check. My third problem is how I interface with the rest of the circuitry, because I do need to use a little bit of circuitry. If I got an edible bulb, I'd probably be on track for a Nobel Prize. So I've got a breadboard, pardon the pun, over here with a battery pack. I've got a little switch. I've got a variable resistor, which I've tuned, and then just a check LED here. So my circuit's working, and what I'm then going to do is then connect in parallel my LEDs, which are going to sit on top of the cake. But how do I get from something like a breadboard, which has small cables with the conductor on the inside, to interface with something with the conductor on the outside? So a little bit of kitchen soldering later, this is what I came up with. So on one end of a regular breadboard cable, I've just put a large blob of solder attached to just a regular hex nut. And that's going to sit on top. It's heavy enough and it's got enough surface area to make a good connection with my gold leaf. How then do I do my LEDs? Well, the same trick again. This poor LED, I've put a blob of solder on each of the feet, and then when that straddles the two edible electric cables, hopefully it's going to light up and I'll be able to pluck it off just as easily as I would a regular candle. So now I'm going to gently bring in my cable, and I need to make sure that I get a good contact on the base, and I'm just going to move that troublesome walnut and just curl it over the top of the cake. So that's one side, and then I'm going to go for tram lines on top. I'm going to turn on the circuit. My check light is working, so this, I just need to make sure I follow the right leg, because LEDs have polarity. If this lights, this will be a minor miracle. Okay, it's dull, but it's there. Can you see it? It's lit, it's lit. And there's two. That's my electric birthday cake. Now, the reason why the check bulb that I have at the back here is glowing a lot more brightly, and I think that's because of some of the losses, because I've effectively got this 0.5 micron layer of gold which I'm bending and distorting. So I've got a good enough connection by spreading out the area to light them up. Hope you enjoy recreating this at home if you're foolish enough to try, but we're breaking new edible electric ground today.
Hi, I'm David Lakin, Head of Education and Safeguarding at the IET, the Institution of Engineering and Technology. Maths is at the heart of all types of engineering and technology, and we believe that it is vital for young people to be equipped with maths skills to be able to consider engineering as a possible career option for them. We work with you, teachers, to provide free, engaging resources and programs which can help to make maths fun and relevant to your students. We want to help you answer the questions that you may get asked by your students. Why do I need to learn this? How relevant is this to me? Does anyone actually need to know this for their job? We've worked with MEI and others to produce a range of maths teaching resources to help you bring a bit of real engineering into your maths lessons. All of our resources are curriculum linked and can be downloaded free of charge from our IET Education website. They are designed to be adaptable and easy to use, so you can pick the ones that you like and drop them into your lessons without having to follow any rigid program. As we work with both primary and secondary schools, all of our resources are designed for Key Stage 2, 3 and 4 and cover some areas such as measurements, numbers, ratios, and for secondary things like algebra and problem solving. Just go to our IET Education website where you can search by a word, a key stage, a topic, duration, or even exam board. We also have classroom poster sets that you can order from our education website, as well as careers material about how to get into engineering for your students and their parents, again, all free of charge. If you want to really show how maths links into other areas of STEM curriculum, take a look at one of our fun engineering programs for schools. By hosting a free Faraday Challenge Day, your students get a hands-on experience of using maths, science and D&T skills to solve real-life engineering problems, as well as having a chance to win a prize. Or get involved in our IET First Lego League programme, and your students have the opportunity to program Lego robots. You can keep up to date with all our programmes, news and our new resources by signing up to our monthly education bulletin. So, lots for you to consider. Please have a look at our IET Education website and don't forget to register for your free poster set. Thank you.